proof of the sine derivative. We are given that f of x is equal to sine of x, and we need to prove that f prime of x is equal to the cosine of x. Well, by the definition of a derivative, we know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Since f of x is equal to sine of x, we can use substitution to rewrite the limit expression as the limit as h approaches 0 of sine of x plus h minus sine of x all divided by h. The next thing that we're going to do is use the angle sum formula for sine of a plus b. It's equal to sine of a times cosine of b plus sine of b times the cosine of a. Well, instead of a and b, we just have an x plus h there, and we're going to apply that to the numerator. So when we apply that, it can be rewritten as the limit as h approaches 0 of sine of x cosine of h plus the sine of h cosine of x minus the sine of x all divided by h. Next, we can rearrange the terms in the numerator to have the terms containing sine of x in the beginning. So in other words, take the minus sine of x and put it in the middle here. So we have the limit as h approaches 0 of sine of x cosine of h minus sine of x plus sine of h cosine of x all divided by h. Then rewrite the single fraction as 2, so the sign between the two new fractions is addition. So where the addition sign is in this long numerator, that's where we break it apart. So we have the sine of x cosine of h minus sine of x all divided by h plus sine of h cosine of x divided by h, and we're finding the limit of this whole thing as h approaches 0. We can factor out a sine of x from the binomial in the numerator of the first fraction. So we can take the sine of x out of both terms, and when we do that, we now have the limit as h approaches 0 of sine of x times the cosine of h minus 1 divided by h plus the sine of h times the cosine of x divided by h. Next, rewrite the trigonometric expressions containing an x out of the fractions. So we have the limit as h approaches 0 of sine of x times the cosine of h minus 1 divided by h plus the cosine of x times the sine of h over h. And then we're going to distribute the limit as h approaches 0 through to both terms. So we have the limit as h approaches 0 of sine of x times the cosine of h minus 1 divided by h plus the limit as h approaches 0 of cosine of x times the sine of h divided by h. Recall the limits involving trigonometry. The limit as h approaches 0 of cosine of h minus 1 divided by h is equal to 0. And the limit as h approaches 0 of sine of h divided by h is equal to 1. If we substitute these values into our equation, we now have the limit as h approaches 0 of sine of x times 0 plus the limit as h approaches 0 of cosine of x times 1. The final step is to evaluate the limits and simplify. So the limit of sine of x as h approaches 0 times 0 is 0, so that first term cancels out. And then we have the limit of cosine of x as h approaches 0. Well, there's no h to substitute it in there, so all we have left is cosine of x there. So then it simplifies to cosine of x. And this proves that the derivative with respect to x of sine of x is equal to cosine of x.